Hello everyone. So in last video, we talked about Euler's theorem on homogeneous functions of degree n. The standard results of Euler's theorem, two standard results actually, and some questions on Euler's theorem and homogeneous functions. Today in this video, we will be talking about some more advanced questions on Euler's theorem, which is based on the homogeneous function of degree n. So just a second. Homogeneous function, Euler's theorem, two important formulas of Euler's theorem we have already discussed in last videos, and this question we have done in last class, and this question as well, which is very important. Now today we will be discussing two more questions which are very important and advanced. So this is first question. If u is equal to tan inverse x cube plus y cube upon x plus y, then show that x del u upon del x plus y del u upon del y is equal to sine 2u, and second x square del 2u upon del x square plus 2xy del 2u upon del x del y plus y square del 2u upon del y2 is equal to sine 2u times of 1 minus 4 sin square. तो जैसा कि मैंने आपको लास्ट वीडियो में बताया था कि अगर आप इन रिजल्ट्स को पार्शियल डिफरेंशिएशन करके प्रूव करने बैठ गए तो आप इट विल बी वेरी लेंथी and answer may be wrong as well, because after so many calculations it is not mandatory that you will get the right answer. तो हमें वो अप्रोच अप्लाई नहीं करनी है. लास्ट वीडियो में भी मैंने आपको बताया था, एंड आई एम अगेन टेलिंग दैट if you are finding these type of expressions, x del u upon del x plus y del u upon del y, or x square del 2u upon del x2 plus 2xy del 2u upon del x del y plus y square del 2u upon del y square, अगर आपको क्वेश्चन में इस तरह का एक्सप्रेशन नजर आए तो यू जस्ट फोकस ऑन यूलर्स थ्योरम फर्स्ट, राइट? So we start. Here u is equal to tan inverse x cube plus y cube upon x plus y. Definitely it's not a homogeneous function, because we cannot convert this function into the form of x raised to the power n function of y upon x, or y raised to the power n function of x upon y. So what we will do, similarly in last video, what we have done, just reverse it, transfer it actually. So tan inverse को इधर ले आए तो tan u is equal to x square plus y square upon x plus y. Now this may be a homogeneous function. This was not a homogeneous function at all, but this may be a homogeneous function. For example, we are saying it's capital U. Now capital U is equal to, take highest power common from numerator and take highest power of x from numerator and take highest power of x from denominator, right? This is x cube here, it's a misprint, x cube, right? तो x की हाईएस्ट पावर अगर न्यूमरेटर से कॉमन लेंगे तो x क्यूब आएगी, और डिनोमिनेटर से कॉमन लेंगे तो x आएगी, बाहर आके x क्यूब अपॉन x स्क्वायर हो जाएगा. सो x स्क्वायर, अंदर क्या बचेगा, 1 प्लस वाई अपॉन x होल क्यूब and 1 plus y upon x. So you can see we can write this expression as x square any function of y upon x. If any expression can be written in this form, x raised to the power n f of function of y upon x, then definitely it's a homogeneous function. And what is the degree of this homogeneous function? 2. So u, keep in mind, this small u naught, tan u is capital U. This capital U is a homogeneous function of degree 2. This capital U is a homogeneous function of degree 2. So we will apply Euler's theorem on capital U only. We will not apply the Euler's theorem on small u, because small u is not a homogeneous function. Capital U, which is tan u, is a homogeneous function of degree 2. Now let's take first part. तो हमने Euler's theorem अप्लाई की. What is the Euler's theorem? Euler's theorem is x del f upon del x plus y del f upon del y is equal to nf. So x del f upon del x. f क्या है यहाँ पे? f वो homogeneous function है जिस पे हम अप्लाई कर रहे हैं. Capital U is the homogeneous function. So x del u upon del x plus y del u upon del y is equal to nf. N is the degree of homogeneous function and f is the homogeneous function. So this n is the degree of homogeneous function and this is homogeneous function. That is nf, that is 2u. Right? Now put the value of capital U here, which is tan u. So x del upon del x of tan u plus y del upon del y of tan u is equal to 2 tan u. Differentiation कीजिए. X as it is. Differentiation of tan u is sec square u del u upon del x. Y as it is. Differentiation of tan u is sec square u del u upon del y and 2 tan u as it is. लेफ्ट साइड में sec square u कॉमन आ रहा है. कॉमन लेके आप उसे राइट साइड में शिफ्ट कर दीजिए. तो लेफ्ट साइड में बचेगा आपका x del u upon del x plus y del u upon del y is equal to 2 tan u divided by sec square u, or we can say 2 tan u into cos square u, because 1 upon sec square u is cos square u. अब इस tan u को आप sin u upon cos u करके कैलकुलेट कर लीजिए. You will get 2 sin u cos u, that is sin 2. Hence 2. This is first expression we have done. Right? ये कैलकुलेशन बहुत सिंपल है. tan u को sin u upon cos u कर दीजिए. डिनोमिनेटर में एक cos u, न्यूमरेटर के एक cos u से कैंसिल हो जाएगा, तो बच जाएगा 2 sin u cos u and 2 sin u cos u is sin 2. Hence 2. So this is first part of this question we have done by applying Euler's theorem. Now move to second part. सेकेंड पार्ट को प्रूव करने के लिए एक्चुअली सेकेंड पार्ट का जो फॉर्मूला है, बेसिक फॉर्मूला है यूलर्स थ्योरम का, वो लास्ट वीडियो में हमने उसका डेरिवेशन भी करवाया था, उसका प्रूफ भी करवाया था. वी हैव डन द होल प्रूफ ऑफ दिस सेकेंड पार्ट इन लास्ट वीडियोस. सो द स्टेप्स which we had taken in the derivation, we will take the same steps here. Right? So we will take the same steps here for this question only. So what we will do, we just do first. We have already proved this expression. We have already proved this expression in first part. So just differentiate this expression with respect to x partially. We just differentiate this expression with respect to x partially and with respect to y partially. So if we differentiate the last expression which we have already proved with respect to x partially, we will get this result. And if we differentiate with respect to y partially, we will get this result. Now multiply this expression by x and multiply this expression by y. I repeat, multiply this expression by x and multiply this expression by y. We obtain and then add these two expressions. इस एक्सप्रेशन को x से मल्टीप्लाई कर दीजिए, इस एक्सप्रेशन को y से मल्टीप्लाई कर दीजिए और फिर ऐड कर दीजिए. तो लेफ्ट साइड में क्या बनेगा? x del square u upon del x square plus 2xy del square u upon del y del x del y plus y square del square u upon del y square is equal to, this is the right side. And what is the value of this expression? The value of this expression is sine 2u, which we have already done in the first part of this question. And this 2 cos 2u minus 1 can be written as 2 times of 1 minus sine square u. Just apply the trigonometry identities and we get the result. So second part will be proved by using the first part which we have already done. What we will do? We just differentiate partially for first expression with respect to x, get the result with respect to y, get the result, multiplying the first expression with x, multiplying the second expression with y, then add both the expressions. We will get this result. Okay. Now next question. If u is equal to x function of y upon x plus g function of y upon x, then prove that x square del 2u upon del x2 plus 2xy del 2u upon del x del y plus y square del 2u upon del y square is equal to 0. Now you can see by this expression that it's nothing but the second statement of Euler's theorem. This is nothing but the second statement of Euler's theorem. And in last question, what we have seen that this expression can be proved only when the first expression of Euler's theorem can be proved, right? But the function, this expression is applying on this function u. It means u must be homogeneous. But here u is the addition of two functions. We cannot say that the given u is homogeneous or not. If it is homogeneous, then what will be the degree? If it is not homogeneous, then what we will do? Right? Because this expression is the second statement of Euler's theorem, and second statement of Euler's theorem applies only the homogeneous functions u. So what we will do now? Because the given function u is not homogeneous directly. Let's see. We are separately assuming the functions as v and w. Let x function of y upon x is v and g of y upon x is w. Then definitely the mother function will be u is equal to v plus w, right? The mother function u is equal to v plus w is not homogeneous, but individually v is a homogeneous function and w is a homogeneous function. V is a homogeneous function of degree 1 because x raised to the power 1 here. And w is a homogeneous function of degree 0 because x raised to the power 0 here. Repeat, u, which is a mother function, which is v plus w, is not homogeneous function, but individually v is a homogeneous function of degree 1 and w is a homogeneous function of degree 0. So individually we can apply the Euler's theorem. It's a v is a homogeneous function, w is a homogeneous function. So we can apply the Euler's theorem individually on v and w. Keep in mind, v is a homogeneous function of degree 1 and w is a homogeneous function of degree 0. So first, we will apply Euler's theorem on function v. X del f upon del x plus y del f upon del y is equal to nf. That is x del v upon del x plus y del v upon del y is equal to nf. Degree is 1, 1 f, f is v. So we just apply the Euler's theorem on v, which is a homogeneous function of degree 1. Similarly, just apply the Euler's theorem on the homogeneous function w, which has the degree 0. So x del f upon del x plus y del f upon del y is equal to nf. What is f here? W is f here. And what is n here? The degree, which is 0 here. So in equation 2, we just apply the Euler's theorem on homogeneous function V, which is of 1 degree, and equation 3 we apply the Euler's theorem on homogeneous function W, which is of degree 0, right? अब इन दोनों एक्सप्रेशन को ऐड कर दीजिए. Just add these two equations 2 and 3. What we will obtain? Left hand side we will obtain x del v upon del x plus del w upon del x, that is x times of del upon del x of v plus w, plus y times of del upon del y of v plus w is equal to v plus 0, that is v. And what is v plus w? V plus w is u, we already assumed. So x del u upon del x plus y del u upon del y, because v plus w is u, is equal to v. So this is equation number 4, or we can say Euler's theorem applied on function v. Oh, sorry, function u. U is not homogeneous function. V and W are homogeneous functions, but we just get the results on U. Now ये हमें जो रिजल्ट मिला है x del u upon del x plus y del u upon del y is equal to v, which is equation number 4. Just differentiate this equation number 4 partially with respect to x separately, partially with respect to y separately, multiplying the result 1 with x, multiplying the result second with y, and then add. देखिए just differentiate equation number 4 partially with respect to x. We have this. आपको मैं partial differentiation भी बता देता हूँ, देखिए कैसे करना है. Equation number 4 का x के respect में x as it is, differentiation of del u upon del x is del square u upon del x square plus del u upon del x as it is just a second, there is some technical issue, just a second. Students, just wait. Yes. So, yes. Okay. Okay. So, this was the expression 4. This was the expression 4. Just differentiate this with respect to x partially. X as it is, differentiation of del u upon del x is del square u upon del x square plus del u upon del x as it is, differentiation of x is 1 plus y as it is, differentiation of del u upon del y is del square u upon del x del y. Then del u upon del y as it is, differentiation of y is 0 because we are differentiating partially, and v del v upon del x. So you can see here x del square u upon del x square plus del u upon del y plus del y del square u upon del x del y plus del is equal to del v. Similarly, if we differentiate with respect to y partially, we will obtain this expression. Expression number 6. Right? Now multiply expression number 4 with x and expression number 6 with y. इसको x से मल्टीप्लाई कर दीजिए, इसको y से मल्टीप्लाई कर दीजिए और फिर ऐड कर दीजिए. So we will obtain x square del 2u upon del x2 plus 2xy del 2u upon del x del y plus y square del 2u upon del y square is equal to x del v upon del x plus y del v upon del y minus times of x del u upon del x plus y del u upon del y. राइट। एंड आप जानते हैं ऑलरेडी कि इसका वैल्यू क्या है, हम ऑलरेडी प्रूव कर चुके हैं, इसका वैल्यू v है और इसका वैल्यू भी अभी हमने इक्वेशन 4 में देखा था v है, सो v माइनस v इज 0, हेंस प्रूव द रिजल्ट। सो ऑलवेज कीप इन माइंड, अगर आपको यूलर्स थ्योरम का सेकंड स्टेटमेंट प्रूव करना है तो आप फर्स्ट स्टेटमेंट को x के रिस्पेक्ट में पार्शियली डिफरेंशिएट कीजिए, फिर y के रिस्पेक्ट में पार्शियली डिफरेंशिएट कीजिए, फिर x के रिस्पेक्ट में जो पार्शियली डिफरेंशिएट करने के बाद में रिजल्ट मिला है उसे x से मल्टीप्लाई कीजिए, y के रेस्पेक्ट में पार्शियल डिफरेंशिएट करने से जो रिजल्ट मिला है उसे y से मल्टीप्लाई कीजिए, राइट, और फिर दोनों एक्सप्रेशंस को ऐड कर दीजिए, यू विल गेट डेफिनेटली द रिजल्ट इफ वी आर टॉकिंग अबाउट द सेकंड एक्सप्रेशन ऑफ यूलर्स थ्योरम। So guys, this is it in Euler's theorem or homogeneous functions. I hope you understood all the questions. We have covered all the variety of questions. When the given function is directly homogeneous, when the given function is not directly homogeneous, and verification of Euler's theorem as well. So thank you very much. Thank you all.